Welcome friends to another session on communication electronics. In this session, we will discuss about the concept of modulation. Modulation is a very important process that is being carried out in almost every communication system. In this session, we will see what is modulation. Also, we will discuss the need of modulation. We will see what is the modulation process, and we will also answer the question that what are the different types of modulation. The concept of bandwidth will be discussed at the end of the session. So friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Khanale. And don't forget to subscribe to the channel. So let us understand what we mean by modulation. Now, suppose you have been asked to travel to the Calcutta city. Now we know that Calcutta city is far away from us. If you decide to go by walk only, then you will find that it will require a lot of time. Even if you decide to go by train, you will find that it may require about 2 days of journey. So the best or the convenient option is that you can pick up an aeroplane, or you can pick up a flight from your nearest airport, and then you can reach the Kolkata within only few hours. So you will find that the plane here works as a carrier for you, and it will take you from one place to the another place within a very short span of time. In communication systems, you will find that the information signal is being sent from one place to the another place. And this information signal is most of the time is a low frequency signal. Say for example, in case of radio communication systems, the audio signal is being sent and the frequency of the audio signal is only few kilohertz. So it is a very low frequency signal. Such low frequency signal, you will observe that it cannot travel a very long distance because there are several hurdles, or there are several attenuations that is being produced for the travel of such low frequency signal, and therefore such low frequency signal cannot travel on its own a very long distance. In such a case, it is necessary that you can send this signal with another signal, and this signal is being called as a high frequency signal. So it is possible that you can send a low frequency signal, which is our information signal, with another signal, and that is a high frequency signal. And when you do this, then you will find that it is being called as a modulation. So we can define here modulation. Modulation, you can say, is a process in which some characteristics of high frequency signal are changed according to the instantaneous value of the information signal. So some characteristics of the high frequency signal are changed. The characteristics such as amplitude, the characteristics such as frequency, or the phase of the high frequency signal is being changed according to the instantaneous value of the low frequency signal or information signal. In such a case, you will find that this information signal, which contains the intelligence, is being called as a modulating signal, and the high frequency signal, which carries this modulating signal, is being called as a carrier signal. And in the modulation, we get a resultant signal, and this resultant signal after modulation is being called as a modulated signal. So let us understand the process of modulation. In the process of modulation, what is being required is first of all the baseband signal. The baseband signal is our information signal, or the signal which contains the intelligence. This signal is called as the modulating signal. Also, we will require a very high frequency signal. So we require some high frequency oscillator such as RF oscillator, and it will generate this high frequency carrier signal. Both these signals, modulating signal and this carrier signal, are connected to a circuit, and this circuit is being called as a modulator circuit. And you will find that whole this modulation process will take place in the transmitter section of the communication receiver. And this modulator circuit will accept both these signals, and that at the output it will produce a signal, and that signal is being called as a modulated signal. So such modulated signal is being coupled to the power amplifier so that its power can be increased, and then finally it is connected to the antenna so that such modulated signal can be transmitted in the space, or it can be transmitted in the surrounding area. Now the question is, why should we need the modulation? Is it not possible that directly the information signal or a baseband signal can be transmitted? You will find that practically it is not possible to transmit the baseband signal as it is. We require the modulation. And there are about 6 reasons can be given behind the modulation. So the first reason why should we go for modulation is that we can reduce the height of the antenna if we use modulation. You will find that whenever we want to transmit any signal in the atmosphere, then we require an antenna. And it is being computed that the height of the antenna should be around 1/4 of the wavelength of the signal to be transmitted. You will find that when the wavelength is very high, then the height of the antenna also becomes very high. Say for example, I am having a signal of 10 kilohertz. Its frequency is 10 kilohertz. Now we know that f lambda is equal to c, where c is the velocity of light, and c can be taken as 3 into 10 to the power 8 meter per second. Now by using this formula, we can calculate the wavelength lambda. If your frequency is 10 kilohertz and if your c is 3 into 10 to the power 8, then you will find that for this frequency, the wavelength will be around 30,000 meters. So if you take 1/4 part of it, then also you will find that the wavelength will be very huge for transmission of such low frequency signal. Now, if I increase the antenna, if I increase the frequency, say for example, my frequency is now 1 megahertz instead of 10 kilohertz, then you will find that this calculation will give me a very low value because frequency is increased and therefore wavelength gets decreased. And now the wavelength will be around only 300 meters. That is, you will find that when our signal is 10 kilohertz signal, then the height of the antenna that is being required is about 7.5 kilometer. Construction of such a huge antenna is practically impossible. And when we increase the frequency and when we want to transmit a 1 megahertz signal, then you will find that the requirement of the antenna height is only about 75 meters. So such antenna can be easily constructed. So you will find that this is the main reason behind the use of the modulation. Another reason that can be given is that when we use the modulation, then the mixing of the signal can be avoided. Say for example, we have nearby 2-3 radio stations, and all of these radio stations are transmitting only the baseband signal. Now we know that the frequency range of the baseband signal is almost same, and it is few kilohertz. When the 2-3 radio stations are transmitting the similar frequencies, then all such frequencies will get mixed with each other. And in such a case, your radio receiver will not be able to differentiate between these frequencies. And ultimately what will happen is that you may hear 2 or more stations simultaneously. So the mixing of the signal must be avoided. And if you want to avoid such mixing of the signal, then you should go for modulation. Also, you will find that the range of the communication can be increased when we use the modulation. When the low frequency signal is transmitted, then such low frequency signal cannot travel a larger distance. But when the frequency is increased, you will find that the attenuation of the signal decreases, and therefore such signal can travel a very large distance. And therefore you will find that a radio station can be heard even at a larger distance when the modulation techniques is used. Another reason that can be given is that when we use the modulation, then the multiplexing is possible. Multiplexing, it will stand for many into one. That is, when two or more signals are transmitted over the same communication channel, then that is being called as a multiplexing. When we do the modulation, then you will find that such multiplexing is possible and it will not mix up the signal. But when modulation is not done, then you will find that such two or more signal cannot be transmitted over the same channel. Another reason that can be given for the modulation is that the modulation will improve the quality of reception. When the signal is received, then its quality is much better when the modulation is used. This is because you will find that the noise effect is being reduced. Noise is the unwanted signal which is added into our information signal, and we want to reduce its effect. So such noise effect can be reduced when the modulation technique is used. Another reason that can be given for the use of the modulation is that the bandwidth adjustment is possible. You will find that there are several channels present in the communication system, and every communication system will transmit the number of signals. Now, there is a requirement of bandwidth for every channel. The concept of bandwidth we are going to discuss later in this session only. There you will find that this bandwidth refers to the range of the frequencies. So some signal transmission may require higher bandwidth, some signal transmission may require lower bandwidth. So such bandwidth adjustment is possible when we make the use of modulation. So why should we go for modulation? We can say that these are the reasons. We will increase the range of communication. The height of the antenna gets reduced. The quality of the reception is improved. Mixing of the signal can be avoided. Multiplexing of the signal is possible. And the bandwidth adjustment is also possible when we use the modulation. So these are the 6 reasons that can be given that why should we go for modulation. Now you will find that there are several types of modulation. Say for example, when your carrier signal, high frequency signal, is a continuous wave signal, then there can be 2 types, such as amplitude modulation and angular modulation. In amplitude modulation, you will find that the amplitude of the carrier wave is changed in accordance with the information signal. In angular modulation, again, we have 2 types. The first type is being called as frequency modulation, and another is being called as the phase modulation. You will find that in frequency modulation, the frequency of the carrier signal is being changed in accordance with the modulating signal. And in phase modulation, the phase of the carrier is changed in accordance with the information signal or modulating signal. But when we use the pulse as a carrier signal, instead of using a continuous wave, when we go for the pulse, then such modulation can be called as a pulse digital modulation. In the pulse digital modulation, again, we have 2 types. One is the digital modulation and another is the analog modulation. In the digital modulation, we have 1 type that is being called as a pulse code modulation. So digital modulation is a modulation in which the digital code is generated, a code that contains zeros and ones, and such code is being transmitted. In pulse digital analog modulation, you will find that there are again 3 types. The first one is called as the pulse amplitude modulation, in which the amplitude of the pulse is varied in accordance with the information signal. Then pulse duration modulation. In pulse duration modulation, the width of the pulse is being changed accordance with the information signal. And in pulse position modulation, the position of the pulse is being changed in accordance with the instantaneous value of the modulating signal. So these are the different types of modulation, and some of these types we are going to discuss in our course of communication electronics. We will be discussing amplitude modulation, frequency modulation, and phase modulation. And later we will discuss about the pulse modulation, amplitude modulation, pulse duration modulation, and pulse position modulation. So many of these types we are going to discuss in our course. Now let us understand what we mean by the concept of the bandwidth. Bandwidth, as I say, will refer to the range of the frequency that is being required for the transmission of the signal. So you will find that in every communication system, there is some highest frequency and there is some lowest frequency. Suppose F2 is the highest frequency and F1 is the lowest frequency. Then the difference between these two frequencies is being called as a bandwidth. So you can say that the bandwidth is just nothing but the difference between the highest frequency and lowest frequency in any communication system. You will find that the value of the highest frequency and the value of the lowest frequency will differ depending upon what type of communication system you are using. Say, for example, if you are using a telephone communication system, then the bandwidth requirement is much lower, because in telephonic communication system, only the voice of the human beings is being transmitted. And therefore, the highest frequency is about 3.5 kilohertz and the lowest frequency is about 0.5 kilohertz. And therefore, in such a case, the bandwidth is about only 3 kilohertz. But if you change the communication system, then you will find that the bandwidth requirement will also get changed. For example, in case of AM radio communication system, the bandwidth requirement is about 10 kilohertz. And in case of FM radio systems, the bandwidth requirement is about 20 kilohertz. So hopefully, friends, you have understood the concept of modulation and why should we go for the use of the modulation or need of modulation in this session. I'm very thankful for you for viewing this session on my YouTube channel. If you have any queries or if you do not understand anything, then you can always write to me and ask questions. Thank you. Thank you for viewing the session.